I have grouped these like terms together by whether they are a coefficient or a power with the same base. We are multiplying. If you have coefficients, you just multiply those together. So 12 times negative 3 is negative 36. But when I have two powers that have the same base, I don't multiply, I add these together. So this becomes x to the fifth power. This becomes y, same base, add them together, y to the negative 2. And this last one becomes z to the 15th. And you're looking at this and you're like, hey, that looks pretty good, except for what? Actually, negative 36 is okay. You can have a negative coefficient, okay? But I'm glad you brought that up. So the negative 36 is okay. Why? Because we can have negative numbers. It's 12 times negative 3. It's just a negative number. We cannot have negative exponents, though. So you're right. Y to the negative 2. What? I'm sorry? Am I slow? I am slow. I am slow. What did he say?
He was saying the letter. He wasn't asking for an explanation.
Oh, so y to the negative 2.
Yeah, that's what he was saying you need to change.
Oh, I thought you said negative 36. You didn't say negative 36 at all?
But then,
Oh, okay. Sorry. I did a little overkill. Thank you for interpreting for me. All right, y to the negative 2. That means you need to move it into the other place of the fraction. That's the only one. And when you move it, you remove the negative sign. So that is negative 36 stays the same, x to the 5th stays the same, z to the 15th stays the same, and y to the negative 2 moves down to be y to the positive 2. And that is your final answer. Excuse me. Questions on that? All right. Someone asked for number 6. Does anybody know what page that is? Did somebody write down the page? The page in your notes where it gives you all the information about 6. I want to say like 9. Nope, not 9. There it is. What is that? Page 10 of your notes. Page 10 of your notes. So, an expression with exponents is said to be in simplest form if these 4 conditions are true. Doesn't matter what order you put them in, but 1, you cannot have, or you can only have, let's put this, you can only have positive exponents. You can only have positive exponents. Okay? So if you have m to the negative 5th, that is not in simplest form, and you would need to change that to 1 over m to the positive 5th. Okay? I know another one is all fractions must be simplified. All fractions must be simplified. So if you have 2/4, you cannot leave it like that. That can be simplified to be 1/2. Okay? Something about powers to powers. You must, how does it say it? I was going to say you must simplify all powers to a power. What does it say about powers? Nope, you got it.
there are no powers of powers.
There are no powers of powers. Okay. There are no powers of powers, meaning you have already simplified them. You cannot say n to the 3rd power and leave a 2 right there. You have to simplify that so it is n to the 6th. So you can't leave a power on a power. And do I remember the 4th? Let's see. Fraction simplified, positive exponents, powers. Oh, one base. You can only have one base of each type, something like that. You can only have one base of each number or variable, something like that. So if you have 3 to the 3rd divided by 3 to the 2nd, you can't leave both of these. That's not simplified. The answer would be 3 to the 1st. Okay? When we come back, we will go over more of these if you have questions, and we'll go from there. 13? All right, let's look at 13. 13. This is adding and subtracting. Adding and subtracting. Radicals. So before you can add or subtract radicals, what do you need to have or do? Guys, look at your papers, problem 13. I know you're tired. I know it's a Monday, but let's do this and get this over with. Number 13, what do I need to do before I can put together those radical numbers, those radical expressions? They have to have the same radicand. So I put these two together. 13 times the square root of 3 minus 9 times the square root of 3. Okay, those are the same. And then I have plus, because of the sign in front, 6 times the square root of 7 plus 5 times the square root of 7. Reagan, please put that away. And you keep the radical when they are the same. It's like a variable. So you keep the radical 3 and you combine 13 minus 9 in front, and that gives you 4. For the other one, you keep the square root of 7 and you combine the coefficient in front. 6 plus 5 is 11. That's a positive 11. Can I combine these two? Do they have the same radicand? No. So you cannot combine them. So this is your final answer. Okay? Does that make sense? Does that make sense? You can only combine if they have the same radicand under the radical sign. And you keep that and you add or subtract what's in front, known as the coefficients. Okay? What else? Anno, did you say you had one? No? 19. Ah, yes. Rewriting radicals into exponential form. So this is in radical form. I need to rewrite it as an exponent, which means I need to have a base and I need to have an exponent. So looking at this, does anybody have an inkling as to what my base would be? 19, yes. The large number is always your base. And what would be for my exponent? It is going to be a fraction. What is going to be the numerator of this exponent? 1. So this 1 right here is the numerator. And what is my denominator? 3. So 19 to the 1/3 power is the same as the cube root of 19 to the first power. And if you look at this right here, this rule right here, a to the 1 over n power is equal to the nth root of a to the first. That's where we get that from. Okay? What other questions? I definitely want to go over 20, and I definitely want to go over 17. Let's look at 20. The cube. The cube is a three-dimensional block, has sides that are all the same length. So this has the same length as this, which has the same length as this, okay? The formula for the volume of a cube is s to the third power, where s is equal to a side. So I am going to take the length of that side, which they tell you is 3m to the 6th power n to the 5th. That is the length of every side of that cube. So I'm going to take that 3m to the 6th n to the 5th, and I am going to take that to the 3rd power, because this is the length of my side. Then it becomes a power to a power. This 3 gets multiplied, by every exponent on the inside of your expression. And if you don't have any exponents, you put a 1 on it. Deviana, please join us. Thank you. So this is 3 to the 1 times 3 power, m to the 6 times 3 power, and n to the 5 times 3 power, which gives me 3 to the 3rd, m to the 18th, and n to the 15th. But wait, there's more, as they say in the commercials. You can simplify 3 to the 3rd power. And remember, you do that by doing 3 caret 3. What is 3 to the 3rd power? Yes. So the final answer is 27 m to the 18th, n to the 15th. And if you are going to be really precise, since you're talking about volume, it would be units cubed. But I'm not so concerned about that. I'm looking for this right there in blue, underlined in blue. Any questions on that? Michaela, do you have any questions? All right. That is number 20. How about let's do number 17. This problem would be worth 3 points. Okay, this problem would be worth 3 points right here. So it says, I'm sorry? No. Which of the following are equivalent? We are giving you all the formulas though, right? Which of the following are equivalent? So if you do m to the 8th, m to the negative 8th times m to the negative 2nd, what would you do first to try to simplify that? You could do one of two things. What would you do first? Okay, how would you combine them? Okay, so you would say m to the negative 8 times m to the negative 2nd is m to the negative 8 plus negative 2, which gives you m to the negative 10. Do we have an m to the negative 10? Do we have that? We do. Letter B. Okay. Now, these say equivalent. This doesn't say that it has to be simplified. And you hopefully will know that you cannot leave m to the negative 10th. So if I were to rewrite that in removing that negative exponent, what would that look like? 1 divided by m to the 10th, right? Do we have that? Yes, we do. That is letter A. Now, it says, which of the following are equivalent? Is there anything else in here that's equivalent to either of those two? Is E one of them? Well, let's see. 1 over m squared times m to the 8th. If I put that together, it would be 1 over m to the 10th, right? So yes, this is equivalent. Are there any more? Actually, not D, C. Yes, because m to the 7th times m to the 3rd in the denominator is 1 over m to the 10th, which is also equivalent. Now, what about D? We said it was m to the negative 10th. Does anybody know where they're getting that 2 from? Me neither. So that one doesn't work. And F, I can tell you what the student did. They multiplied there, right? Which is not correct. So 2 times 8 is 16. That's not correct either. But I want you to know, just because it is worth 3 points does not mean there are only 3 answers. You need to look at each problem separately in each answer. All right? So A, B, C, and E are all correct there. All right, what other questions? What other questions? 12 is a really good question. 10 is a really quick question. Number 10, what's the answer to number 10? Yes. Anything, if it's all to the 0 power, is 1. Please do not give me 0 tomorrow. Don't make me cry. 16? Somebody say 16? Yes? All right. 16. I do want to go back to 12. 16 is at the bottom of this page. Ah, yes. My last class asked me about this. So I need to divide these up according to if it's a coefficient, if it is a power of one type or another. So I'm kind of dividing them up like this. And what is the main operation going on here, Amani? Am I adding, subtracting, multiplying, or dividing in general? Yeah, we're dividing. So keep that in mind. So first up, I'm just going to rewrite them so they are kind of put together. 36 divided by 6, that's your coefficient. Times, then I have h to the 0 divided by h to the negative 3rd. I have j to the 8th divided by j to the 7th. And I have k to the negative 1 divided by k to the negative 5. Okay? So does everybody see how I've divided those up? All right, what is 36 divided by 6? 6. Okay? Then I have h to the 0 divided by h to the negative 3. There are 2 different ways you're going to do this. I'm going to do one way, and then I'll come back and show you the other way. If I am dividing 2 powers that have the same base, you can keep the base, and what do I do with the exponents? Subtract. So this becomes 0 minus a negative 3. 0 minus negative 3. But we can't have that double negative, so you add the opposite. And I'll come around and clean that up later. All right, so let's look at j. J to the 8th divided by j to the 7th. Same thing. When you divide 2 powers that have the same bases, you subtract. So this is 8 minus 7. And finally, k to the negative 1st divided by k to the negative 5th. You can also do this one 2 different ways. I'm going to show you the first way, which is what we've done with all of these. k to the negative 1 minus negative 5. Again, you have that double negative. Subtracting a negative changes that to a positive. So let's clean it up and see what I have here. I have 6. H to the 0 plus 3 is h to the third. J to the 8 minus 7 is j to the first, or you don't have to put anything on it. And k to the negative 1 plus 5 is k to the fourth. This is your final answer. Now, I told you for 2 of these, there is another way to do it, but you will get the same answer. H to the 0, anything to the 0 power is 1. And 1 over h to the negative 3, you can't leave a negative exponent there. Excuse me. So this would move up to the top and become h to the third over 1, which is still what we have here for h. So that's why that's the same. Excuse me. Over here, k to the negative 1, k to the negative 5, you can also move the negative exponents. Move the k to the negative first down, move the k to the negative 5 up, and that gives you k to the fifth power divided by k to the first. And then when you subtract, you keep and get k to the 5 minus 1, which is 4, still is the same. But again, on some of these, there are 2 different ways to do it. Okay? All right, other questions? Number 9, yes. Number 9. I still want to do 12, I think it is. All right, simplifying. This is called a power to a power. Okay? 2 different ways to do this one. The first way, what I would do is simplify inside the parentheses first. Okay? So I would say we've got a 3 over 5, that's in simplest form, times r to the 6 divided by r to the third. So you would subtract r to the 6 minus 3. And you have t to the fourth divided by t squared, which is t to the 4 minus 2. And then all of that is going to be squared. This is one way to do it. So this would be 3/5. R to the 6 minus 3 is r to the third. T to the 4 minus 2 is t squared. I'm just going to extend this. And then we have to do square everything on the inside. If it does not have an exponent, put a 1 on it. So this means you are now multiplying 2 times 2, 2 times 3, 2 times 1, and you also multiply by anything that has an exponent on the bottom in the denominator. All right? So that becomes 3 to the 1 times 2, r to the 3 times 2, t to the 2 times 2, all divided by 5 to the 1 times 2, which is 3 squared, r to the 6th, t to the 4th, all divided by 5 squared. And you're like, hey, that's pretty good, but you can simplify these numbers that are squared. 3 squared is 9, r to the 6th, t to the 4th, all divided by 5 squared, which is 25. That's one way to do it. The other way, I'm going to do this down here, is to say 3/5 are, oops, that stopped, and to square everything right away. R to the third, t to the fourth, divided by t squared. If this is all squared, take 2 times all of these and 2 times all of these, and then simplify. So this is 3 to the 1 times 2, r to the 6 times 2, t to the 4 times 2, all divided by 5 to the 1 times 2, r to the 3 times 2, t to the 2 times 2, which is 3 squared, r to the 12th, t to the 8th, divided by 5 squared, r to the 6th, t to the 4th. Yes, I am going over this kind of quickly because it's a second way. And since you are dividing, you would subtract the exponents for the ones that have the same base. So this gives r to the 12 minus 6 is r to the 6th. T to the 8 minus 4 is t to the 4th. 3 squared is 9, all divided by 5 squared is 25. It gives you the same answer. Same answer. Other questions? I do want to go over 12. Has anybody finished 12 yet? Okay. Yes. 12. Use cake method or an appropriate method. I would say for most of you, it needs to be the cake method for any square root. So 42. Cake method, you put it down, it's an even number. So Brian, what can I divide that by? If it's an even number. Any idea? 2, good. 42 divided by 2 is 21. 21 is not even, so you check. See if it's divisible by 3. Yes, that gives 7. 7 is a prime number, so we can divide by 7, and there's my 1. What do you notice about the prime factorization of 42? What do you notice about it that's different from a lot of other numbers that we've had? There's no pairs. Yeah, there is no pairs right there. So your number will still be the square root of 42, but we need to do d to the 4th. And Dwayne, this is kind of what we were looking at before. D to the 4th, what would I do since this is an even? I would need to divide by 2, right? And that rewrites it as d to the 2nd times d to the 2nd, right? So I write that, d to the 2nd times d to the 2nd. And then I have e to the 5th, but I can't divide that by 2 because it's odd, so I'm going to take 1 away and make that e to the 1st times e to the, do you know? What's 5 minus 1? 4. Now this is an even number, so I'm going to take that and divide it by 2. And this becomes 4 divided by 2 is e to the 2nd times e to the 2nd. But I need to include all of these to get e to the 5th. So e to the 1st, e squared, e squared. Circle your pairs. Notice there are no pairs in those opening coefficients. So when you multiply those together, you still have 42 there. D squared, yes, that comes out in front. D squared. E squared, yes, you had 2 of them. Only take out 1 out in front, so that's e squared. So I already multiplied those, and I have 1e here. So final answer is d squared e squared times the square root of 42e. Did you have that? Yeah. Good. Other questions? We probably could do one more. One. Let's take a look at 1. Simplify. What is the main operation happening here, Kamari? Am I adding, subtracting, multiplying, or dividing for number 1? What? No. No. Multiplying. Yes, we are multiplying. So put together -5 times 4. That's your coefficients. Put your j terms together. J to the 3rd times j to the 7th. K to the 5th times k to the 1st. And putting it all together, -20. When I multiply, what do I do with the coefficients? Not the coefficients, the exponents. Add 3 plus 7 is 10. And k to the 5 times k to the 1st is k to the 6th. Final answer is -20, j to the 10th, k to the 6th. All right. I will include all work and all answers for the rest of this. This is due tomorrow. I will include it on today's Canvas page. However, Canvas is not working, so you might have to actually do these problems. I know a lot of people look at it and compare. I know a lot of people also copy. Okay? It's not that we teachers don't know, but yes, we're trying to make sure you do understand. I will put it on the important page. Everything for chapter 10, I will also put it on today's page. Okay? All right, I will be over at my desk. If you have more questions or if you just want to check on other answers, we can do that. This is study hall. This time is yours. Okay? All right. And homeworks. Thank you. What instrument do you play?
Hey, clarinet.
Clarinet? Very nice. My youngest played clarinet. Very good. Enjoy. I have a lot of zeros for homework. Make sure I have your homework, okay? Lots of zeros. And remember, if you don't turn the homework in, you can't do a retake.